So in this question here, we want to find all the solutions of x squared minus 4 divided by 3 minus x is less than or equal to 0. So let's write the question out here and let's just have a look what's going on to see how we can go about finding our result. Now, what we want on this side is something that's going to be negative. So that's the first thing we need to sort of see here. Also, 0 is allowed. So it's not a strict inequality, we've got 0 included. Now, if I plug in here 3, I've got something divided by 0. So straight away I can see that x does not equal 3. That's the first thing we can take from there. Next, we can see with an algebraic term in the denominator, I can't just multiply both sides by 3 minus x. That's going to break some kind of rules, because if I do that, if x is greater than 3, then I've got a negative term here and I'd need to change my inequality sign. So to avoid that, I'm going to multiply both sides by 3 minus x squared. So if I just write that out here, 3 minus x squared. I'm going to write this out on another line here, showing all my steps. So I've got x squared minus 4. Put that in a bracket because I'm now going to multiply by this one. So I'm going to write it out in expanded form. 3 minus x divided by 3 minus x. So now we can see clearly what we will do. And the same on this side. 0 times 3 minus x squared. Obviously this is a trivial part, but just to show it that I've multiplied both sides, I know this will now cancel out. Now on this side, I've got 3 minus x in here, and as they're all multiplied, I can cancel these out. So that becomes 1, and that one will cancel out. So let's rewrite this inequality. X squared minus 4, 3 minus x less than or equal to 0. So what I'm looking for is when we've got a negative value or a 0 on this side. Now I can't have 3. I've already outruled that one from our solution set because of that. So we can't put 3 in there to get less than 0, but we could have that when that becomes negative. So what happens when that becomes negative? Well, we need a value of x greater than 3. So that would make that as a negative. So x is greater than 3. That's possible. If x is greater than 3, what happens here? Well, here my x squared, anything greater than 2 will make a value that's positive. So if I put a 3 in there, I'm going to have a positive number times by a negative number. So that would make my inequality good. So if x is greater than 3, this is definitely a part of my solution set with regard to this one anyway. Now what about here? Now x squared minus 4. Well, x squared minus 4, I can rewrite that if I like as x minus 2, x plus 2. It's just a difference of 2 squares. So why don't I just rewrite this inequality with that on here? X minus 2, x plus 2, 3 minus x less than or equal to 0. So then with that written out like that, I'll have another set of inequalities which is going to give me a value of either plus or minus a positive number. So a positive or a plus or a minus number. So if I plug in there 1, I'm going to have 1 minus 4, which will give me negative 3. And then plug in a 1 there, I've got a positive. So I'll have a negative times by a positive. So I want values between 2 and minus 2 in there to make this a negative, and then this one here would be a positive. So then my solution set with regards to this one, I'm going to have x is less than positive 2 and greater than minus 2, but also I can allow it to equal 0. So if I plug that as an equal sign in there, that will also work. And also to put 2 in there is fine with my denominator. So my solution set, we've now got it, is from minus 2 to plus 2 for x here. So that's one part of it. And also we've got x greater than 3. So that'd be my solution set for this x squared minus 4 divided by 3 minus x less than or equal to 0. So all of those numbers will give me a positive result for that question. Okay.